All right. I think we are live.
Yeah.
Hello. Welcome, everyone. Happy Thursday. We are just at the top of the hour here, so I'm going to go ahead and kick off our panel discussion for today. My name is Heather Grant. I am one of the community admins for the Maintenance Community by Upkeep. Thank you to all of our attendees and all of our panelists for joining today. If you are not already a member of the maintenance community on Slack, we would love to have you join us. We will add the link in the chat shortly. Today, I have with me some wonderful experts in the maintenance and reliability industry. I will let them all introduce themselves in just a moment. But the recording from our panel today, as well as all of these wonderful panelists here, will also be available in the Slack community tomorrow. We will be going through a live discussion. I have some questions prepared, but please feel free to share questions as we go in the chat box on the right side of the screen, and I will ask those, incorporate those into our conversation. We'll also have some time at the end to answer any and all additional questions. I think that's all from me in terms of housekeeping and everything like that. I will go ahead and kick us off. So I'll actually pass it right back to all of you. Would everyone mind going around introducing themselves, sharing a little bit more about you, about your background, your current role, maybe a previous role, where you're based, hobbies, any fun facts, anything like that, just to get us started here. I guess we can go kind of in a round circle motion there. Andy, would you like to kick us off?
Yeah, I'll go first. I'm Andy Gailey. I'm the owner and founder of the smallest consultancy you can get in here in Coventry in the UK. So it's myself and my partner Jenny. We both come from an engineering and production engineering background. We're in the UK. We both love travelling, so that's on hold for now. But we have an old 1970s Volkswagen camper that we've restored, so hopefully that's going to come out this summer. I started with my first 20 years was in production engineering, so I was involved mainly in prototyping, turbines and in motorsport. And then I had enough of cars going round and round rally tracks and things like that. So I went into the food industry and I worked for PepsiCo for 20 years. I went there as everybody does, go there for 2 years and then end up 20 years. And then in 2015, we both got the opportunity to leave as the business transitioned into a new way of working. So we both kind of checked out and I started Uptime Consulting straight away because I'd already got a plan of bringing together all of the aspects of engineering, reliability, lubrication, prediction, strategy together in one place. So now I go to clients and I can offer them, they might be looking for lubrication, we find out they need criticality. They might think they want RCM and they really need RCA. They're too far ahead of the curve. So a fun fact, I thought, that was a good question. I'm a freeman of the city of Coventry. That means I get to, if I've got sheep, I can go and graze them on common land. The Freeman's Guild was restarted in 1946, just after World War II, and it involves all of the trades that serve apprentices. It dates back to the 1300s, and the first recorded apprentice that served time was a teenage girl in 1336. I've just written it down, and she was a purse maker, and she would have served 7 years as a apprentice to what they call a widower. A widower was a leather maker of saddles and bridles and things like that. So that's a fun fact.
That's very fun. I love that. I love that this one was female. Yeah, not just me, but
the apprentice guilds, the guilds were around for a couple of centuries until because of their connections to religious organizations. Henry VIII didn't like them, same way as he didn't like the monasteries, so he dissolved them because they were quite powerful in the cities. So nearly all the trades guilds, they were in London and Chester and Coventry, they were all dissolved by Henry VIII.
Very cool.
Very cool.
Learned something new today.
Yeah.
Oh yeah.
Awesome. Sonya, I'll pass it over to you.
All right. So I am Sonya Matura, and I'm based in Trinidad and Tobago. If you don't know where that is, you need to check that on a map. We're in the Caribbean, but I'm just going to jump to my straight fun fact. We have 2 seasons in Trinidad. We have the dry season and we have the wet season. That's it. We're in the dry season right now, and certain parts of Trinidad have been flooded. Fun fact. So even though it's a dry season, there's a lot of rain. So I am the owner and the founder of Strategic Reliability Solutions Limited. My background is a bit different in that I have my bachelor's in electrical and computer engineering. So yes, I can program, I can code from a black screen back in the day. Now we have all these fancy apps, so it's so much prettier to look at and much more efficient. But after doing that, after doing my bachelor's, I got into the industry and I did a little bit of that. And then I started working with Shell. And when I was introduced to the equipment and lubrication, I fell in love with reliability. So after doing that, then I did my master's in engineering asset management, which is, a lot to get around. But while I was doing my thesis, I realized that I wasn't putting my best foot forward, and quality is very, very important to me. So I left my job just to finish off my thesis. And while doing my thesis, I realized that the information that I was looking for, it wasn't readily available. You had to know somebody who knew somebody who knew somebody else, but the information was there. And that's what helped me to start the company, in that I wanted to be the main focus point where people could come to for information. And with Strategic Reliability Solutions, that's how we bring different reliability solutions. So Bob is an affiliate with us. So he helps us with our CA training. We have affiliates in Canada, Jesus and whatnot. They do RCMR. We have affiliates in Australia who are doing maintenance planning and scheduling. So we have affiliates throughout the world, and what we focus on is quality and bringing that quality to the people that need it the most. So that's the core at Strategic Reliability Solutions. And oddly enough, the thesis that I wrote that I quit my job for, I wrote my first book off of that. So maybe it was a good choice, right? And Bob is gonna bring that book out. Oh yeah, I know he has a copy. That's it from me.
Blair.
Awesome.
Is it? Am I next on the? I think we have different screens here. What a circle is, but okay. Well, hello everybody. My name is Blair Fraser. I serve as the director of global IoT solutions for UE Systems, which is an ultrasound technology company for predictive maintenance. I also host or co-host a podcast, which you may have heard of in this community, called Maintenance Disrupted. I would highly encourage you to check that out. And I really started in this field. Well, not in this field, but I started off in the trades as an industrial electrician. So installing, maintaining equipment. In fact, I often joke about this because in the role I was in, I had to lubricate motors. And I feel like I should go back to the employers and apologize for all the premature bearing failures I caused because of a lack of education, right? It was taught to me handed down through the electrician that taught me. Squeeze the grease in until it comes out. That way you know you got everything in. And that's what I taught. And then I didn't, luckily, no one did an apprentice under me, or I would have taught the same thing and the same thing and the same thing and the same thing, right? And I did go back to school. I realized, like, working outside, I'm from Canada, you might hear an accent. So we have 2 seasons here as well, cold and just not as cold, I guess. I realized, geez, working outside in minus 40 is not ideal. So that's why I'm like, I'll get into maintenance reliability. You get to sit in an office all day and tell people what to do. And I was wrong with that as well. And that's what brought me in. But underlying what really my passion is technology. Now, I understand the importance of proper foundations and everything that everyone's going to preach. But I still believe we undervalue technology and focus, and often can stop implementing technology because we think the foundation is not there. So that might be a heated topic for this discussion, but I will speak on the side of technology for this discussion.
All right, I'm on deck. I have two fun facts. I'm the youngest one here.
Sure. you don't age very well, Bob.
And I'm not a lube expert. I'll just give a quick background. Is that I'm CEO of a company called Reliability Center, which is actually a 48-year old company, which started as in a corporation called Allied Chemical Corporation, which is today is Honeywell. The reason for my job, and this is a plug for nepotism, is that my father had started the director and founder of the Reliability Center for Allied Chemical Global in 1972. And in doing that, their research focused on equipment, process, and human reliability. And in 1985, he retired, and then he bought his group out of the corporation. So that's where my job opportunity came in. You know, you automatically got a title when you were part of the family. So for 36 years, I've been in the business of equipment, process, and human reliability. And I can safely say that reliability is not a job; it's a way of life. Because my father, our house had a PM plan in it. There was design and reliability in the blueprints of our house. So you know, I just grew up in a world that was taught to be proactive about everything. And then I am not a lubrication expert, but in the nature of our specialty is in root cause analysis, is that we deal with failures of all kinds. And I depend on people like my esteemed colleagues on this staff that when we carry people through a thought process of why things go wrong, you absolutely need subject matter experts to fill in the blanks. So I'm just a guy who's an expert at asking a lot of questions and you know, making people frustrated because they don't know the answers. So that's my short story. Other than my slave to fashion side.
That's wonderful. Thank you all so much for sharing a little bit more about yourselves. I do want to ask kind of a pointed question that I think will play off a lot of kind of some of what you've shared in your introductions. But one thing that I'm particularly aware of is people just starting out in the field and getting more people starting out in the field, right? So one question I love to ask experts and just people in the field when I'm talking to them is, how did you first get into maintenance and reliability? I think, you know, we definitely heard a little bit from each of you on that, but how did you first get your first job in maintenance and reliability? What was it like kind of starting out? And then how did you get to where you are now? How did you find your field of expertise and your passion, whether that is asking a lot of questions or lubrication specifically? I'd love to hear a little bit more kind of about that initial start in the field.
Yeah, well, I'll go first again.
Cool.
So as I say, I was a production engineer. So I worked in industry where I removed metal from other bits of metal and made gearboxes and transaxles and transmissions for jet aircraft and things like that. And then I answered an advert one day in a local paper that said, it was a blank advert, and he just said, time served, engineers required for challenge. So I applied for it, and then about 2 months later, as I went through the process of selection centres and interviews and psychometric tests and all the rest of it, we still didn't know who it was. And then at the final stage, they said, "Oh, we're PepsiCo International, and we're going to build the first Dorito plant in the UK, which is the first one in Europe." It's still the only one in UK, and it sits in my hometown, Coventry. And I had all these engineering skills about making things, and they said, "Well, we want to apply those skills. We want to transfer them to installing lines, maintaining lines, running production lines." So the first kind of couple of years were really everything from hosing the floor sanitizing fryers, climbing up gantries to replace motors, look after 4 or 5 operators operating bagging machines, the whole 9 yards of kind of real deep dive into how a snack food facility works. And that went on for around 10 years. I kind of moved from area to area. So I was processed and packaging and multi-pack and all these different areas. And then one day the maintenance manager said, as you can see, lots of things are breaking. We'd like you to step to one side and come up with a lubrication and predictive strategy to fit in with this new thing that we've just been talking about. So we'd had an RCM deep dive for 3 days with a consultancy, and they came in and they said, you think you're this small percentage downtime, you're this large percentage downtime, really. So then PepsiCo are really good because they let you try things out and fail a lot and then succeed. So I spent about 3 months trialing different ways of how we could fit it to our equipment. That's lubrication and condition monitoring. We came up with three aspects of condition monitoring we'd use, and but the main thing was the right lubrication, the right place, the right specification, right quantity with the right training, and you can pretty much wipe out all of those reoccurring failures in rotating equipment. So I got to develop that over 9 years, and then I left after 9 years. So I'm still a production engineer. I'm a mechanical production engineer by trade, and I still think as a production engineer. So production is first, and the reliability of that equipment is due to the either invasive stuff we do to equipment or the things where we monitor it. So I always have the analogy of when you go to a doctor, he uses certain tools, and they'll be to do with hearing. So it'll be stethoscope, it'll be temperature. So he'll take your temperature, he'll take your blood pressure. So it's like oil. And you do all these things to equipment, and then you come up with a prognosis about whether they're good or bad. And in the company I was in, we wanted to know, did we have to take action or not? There was no fancy stuff in there. There were no turbines. We needed to know, is it going to last another 3 weeks for another Dorito run or not? So it's pretty much a black and white. Is it good to go or is it not? And then we'd have strategies in place to continuously monitor that by hand, so route-based. And then we did involve some remote stuff as well over time, but not a lot, to be honest. It's very low level. So that's me. I fell into it. And I think that's a book I'm thinking of writing. I'm thinking of calling I Fell Into Maintenance. Because most people do.
Very cool. Awesome.
So, Sonya.
The same order or yeah.
Andy, I just hope that you did a lot of quality testing on those Doritos, If I find a Dorito that I don't like, I'm going to definitely come to you about it. Now that I know.
Like I say, we used to do hourly checks for product quality, taste checks, smell, taste. And that was a novelty for about the first 2 or 3 weeks. But if you're on a 12-hour shift and you have to eat a product you don't like every hour on the hour.
Oh my gosh.
That's motivation.
Yeah.
Oh yeah. Well, in terms of how I got into the maintenance sector, and because my bachelor's was electrical and computer engineering, it has nothing to do with oil. Not a thing to do with oil. So I did almost similar to Andy. I did apply for a technical position with a distributor in Trinidad who they were distributing Shell. And I remember going for the interview and coming back, and afterwards somebody from the panel calls me and they're like, we really like you. You have 2 things going against you. You're female. I'm like, okay. And you're young. Everybody else who interviewed for this position, they were older, they were male, they knew the industry. But the guy also said those 2 things can work for you. You're female yes, that's fine. But I also know that means that you're going to push harder than everybody else. You're young, so you can't be molded into anything. You don't have these preconceived notions that, this is how it should be, or this is how it has to be. You're open to new ideas. And that's how I got thrown into it. So I fell into it. Let me use Andy's words. And after meeting with clients and customers and realizing that lubrication was such a huge part of maintenance, I fell in love with the idea of it and the fact that it is part of reliability and the fact that we could actually help solve problems by just changing certain things, understanding your lubricant, how it works, troubleshooting, because we did a lot of troubleshooting. So that's how my background got involved there. And while I was writing the book last year during COVID, I did my MLE. I got certified as a machinery lubrication engineer. So I'm the first female in the Caribbean to get certified. So we're happy about that. And when I saw the program from ICML, it captured everything. It captured asset management, it captured lubrication, it was everything that I needed. And it had one certification in one place. So I loved that fact. And I love the fact that I can help people to understand stuff about lubrication that they didn't know before, or break it down to a very simple, easy to understand, jargon. It's not all smoke and mirrors that you see all the time. So that's the part that I really like about, just being in lubrication and being in maintenance and reliability. Because I think in maintenance and reliability, we have a different approach in that we are more focused on helping the people around us. We have a community spirit, and that's one of the best things that I like about it. I'm going passing this over down to Blair. Yeah.
Got it. Did that work out? Did that actually work? I don't know if it actually did or not.
I can get it.
So I think the first thing is understanding maintenance and reliability are separate. It's like, how did you get into maintenance and safety? Well, it's just part of the maintenance job, right? To not kill anybody. So how I got into it and why I'm still into it, and very honest and very candid, is selfish. It's very selfish. It's money driven. So when I started off as an electrician, where did I make the most money? In industrial. I went to an industrial, started making money doing that, right? And then what happened was I was the only person with the skill set and the training to maintain electric motors, for example. So what would happen is, as a young person, nothing but time and the money and the drive, is a failure. It was a bad thing for the company, but it often a good thing for me, because it meant money. Oh, I'll come in on a Saturday, double bubble, baby, 4-hour minimum. You stock, because it doesn't cost me anything. You stock that motor. I'll grab it from stock. I'll throw it in. I'll do it in less than half an hour, charge you 4 hours. I'm on the road, right? And which was fine. I made a whole career out of doing that, right? But what happened, this is how it got me the technology piece. If it broke down and I got called in on a long weekend, like, right? Do I want to go in? This sucks, right? So that got me into the technology side. Well, how do I monitor to see if I can actually make it through this long weekend, right? I still want to come in overtime and replace it, but I don't want to give up my long weekend, right? And then eventually I progressed in my career and I became the owner of that P&L sheet of the maintenance. And I'm like, oh my gosh, we're spending a lot of money for people like me to go replace this, right? And that's what really got me into reliability. And then I realized, the MRO spares, the condition monitoring, all that kind of stuff we can do, which got me into which I think we all need to understand, is that the financial and the cost center of impacts of all those decisions. So that's how I literally got up from really selfish to this day, right? I'm very selfish with technology as well. So that's what got me from maintenance and into reliability. Now, I was also very lucky that where I'm based out of Toronto, and Jesus and all these people who know this, there's, a lot of great thought leaders. Some are on this chat to begin with. Kudos to Cliff Williams and all those people that, took me under the wing and really mentored me as well. And I learned from all those people. And that's what really pushed my career from maintenance into reliability.
All right. Hold on.
Something wrong with it. There you go.
Well, I think I've already explained my nepotism route to where I was at, but I do want to tell an interesting story on the difference between reliability and maintenance. And if you can imagine those who are having trouble starting a reliability group or maintaining it today, try thinking doing it 50 years ago when nobody could spell reliability and didn't know what it was. Because one of the things in that day that when it hasn't been established before is that where does it go on the organizational chart? And naturally, the corporation was trying to push it subordinate to maintenance. And I remember my father telling me the stories to say that was going to be impossible because maintenance was a today function and reactive, and reliability is a tomorrow function. And if you put reliability subordinate to maintenance, you will be very little time you will get to reliability work because the urgent will take over the important. So on the at that time on the organizational chart, reliability was isolated from maintenance for that reason, and that was the difference between proaction and reaction. So when I came out of school, the reason I got into it is obvious. Is because I grew up in the University of Reliability, but I went into a reliability department and I did the vibration and eddy current and ultrasound and my specialty at that time was infrared imaging, which was with a specialty in building envelopes and built-up roofing systems. Now, to show the age, that's when I had to carry around that 300-pound cart of infrared imaging equipment with liquid nitrogen and all of this other stuff. And I was watching Greg Stockton on one of the maintenance communities videos, webinars, and he's showing me a FLIR plug-in to a phone, to your phone. So that's how far that technology has come these days. But everything in terms of this topic, this is why I'm pretty flexible in any industry, because I don't care what an undesirable outcome is. I'm in the business of the human being thinking through why it occurred, how it occurred. So, whether it's a lubrication related thing, I deal with, why kids get bullied in schools, why packages are late for UPS, why terrorists do what they do. The thought process you go through thinking that is the exact same. So in this instance here, and I guess the reason that everybody's wondering, well, what the hell is he doing here? It's just because I deal with a lot of lubrication related failures, of which, you come in and it surfaces because a bearing fails or, gears fail or whatever fails, the shaft. And then the equipment's shut down. And then that's where, people have to come in and analyze things. And, we'll get to it in a little bit, but Sonya and I work closely collaborating on things like this to be able to build logic associated with the, when you're dealing with the physical sciences, it's very determinable as to what the cause and effect relationships are. When you get into the human beings and understanding decision making, it's not quite, it's a bit foggier. But certainly for the physics of failure, there's a lot of determinability that's already preset. So we'll talk about that a little later. And then Andy, you're next.
Maybe.
Thank you so much for sharing a little bit more of your story and your background getting into the field. I love to highlight it, and I think it's awesome to kind of help people understand that there's so many different avenues, and everyone's story looks a little bit different, but all of them are right for you. So I'm going to switch gears here a little bit, getting more into our subject matter today of troubleshooting lubrication failure. And I'm going to ask a pretty big question with some different parts to it. But just kind of starting us off, thinking about lubrication failures, what are some typical warning signs that equipment shows that the equipment is failing due to lubrication? For maybe everyone can give one or two examples of those typical warning signs. And for that, what's the course of action? So you see a warning sign, and then what? Do you memorize kind of all of the different potential course of actions, or are there indicators that'll take you down different paths of troubleshooting? Could you walk us through maybe kind of from warning sign to course of action to solve the failure? I know that's like a big question, but That's kind of my train of thought there.
I'll go
And
first
then we
again
can go in
then.
any order. So
Yeah.
yeah, go ahead.
Yeah. So going into, I mean, most of my background is from the snack food industry, lots of ovens and fryers and transport conveyors and things like that. Although I do work across other industries now, so I work across automotive and utilities, and all of these assets pretty much do the same thing. So things that you find in sewage systems look a lot like they do in food factories and vice versa. So that's the one thing that I always say is if you see a failure mode that's down to lubrication, it will be repeated in other industries, whether it's automotive or a utility or a food factory. And one of the first things I was challenged with, because you are challenged at PepsiCo, I was challenged with oven bearing failures. So if you've got a TC oven and a bearing fails, it becomes a safety issue straight away, because you have to have permit to work, has to be written up. It's at least a two-man team to replace the bearing, because we're talking bearings that operate at over 200 degrees C. So it's quite a long job. It ends up hours to replace one bearing. It usually does collateral damage to belts and guides. So the first thing I noticed as an engineer asked why things happen is that the lubricant was running out of the bearings continuously. So as soon as you put the lubricant in, this was right early days when I didn't know much about lubricant. As soon as you put the grease in, it kind of ran out as a black oil. So it was actually just it was crushing that oil straight away. It was it wasn't staying in the bearing. So it was obvious to me that if you can't keep the oil in the bearing pack, then they're going to fail. So straight away I put on one of my root causes. It was the lubricant that wasn't doing its job. So we started looking then for a lubricant that would go above 180, 200 degrees C. And we got one, and it took some months. So over time, we had to change bearing packs out and make sure that they had this new lubricant in. And then the next step was to it's allied to ultrasound. My speciality was acoustic emission, which operates at a slightly higher level to ultrasound. It looks for it's more like stress wave analysis. It's very minute impacts in bearings, and we could then go around there every week and check all of the bearings with a condition monitoring device, and we could call those bearing changes earlier. So we went from having many failures, which cost tons and tons and six-figure sums of unplanned downtime, down to 2 years later to zero. And that's just one example out of a bearing that was in a TC oven. So yeah, I mean, the other thing is when you do see things fail, is make sure you get to the nth degree. So don't just throw that bearing away. I always used to keep them in a black museum, and I used to disassemble them. Even had SKF representatives in a couple of times to go through the failure mode that we'd found and whether that was acceptable for that life of bearing in that particular asset. So there's a lot to learn, but as Sonya said, there's a lot of people in the community that help people out, and I try to help people out freely. My job now at this time of life is trying to unload all of this information into people that have got to carry on and carry the baton, so to speak. So yeah, over to you, Sonya.
So I guess you're passing it over. I'm taking it here. So I think what you spoke about exactly, once you have lubrication failure starting to occur, the first thing that you notice is a change in temperature. That's the first thing. So you start seeing that rise in temperature, especially with your bearings. So you would start seeing, and I'm going to talk about it from more of an oil standpoint. If you start seeing temperature spikes and you start seeing misalignment of your shaft, it could be that you have varnish building up on the inside of your equipment so that your bearings are no longer going in a complete circle. So the shaft is misaligned because you have that varnish at the bottom. until it clears it away. And then you have that spike in temperature, you have that difference in temperature, you have that change in your vibration analysis. So I think so one of the things definitely to look for when you have lubrication failures, it's either it's a degradation of the lubricant, either you have too much lubricant or too little lubricant. So it's either of those. And I know Bob and I have been working on some stuff, and you've been going, how can it fail? And we've kind of gone back and forth on how to get something like a template for somebody to follow, somebody in the field, somebody that could, you know, they're experiencing these sort of issues. What do they look for? What can they check on? What, you know, your telltale signs? And one of that is temperature. Another is check your vibration analysis. They will tell you if something is going on. You're going to start seeing, and what you would want to do rather is relate that to what's going on in your process. Is it that whenever you do a factory run, that during that time, that's the only time that you start seeing your temperature rise? So you want to correlate it to what's going on in your processes in your situation, because every single plant is different. Even though they may be exactly the same, the culture is different. So the people, and we can't control that part, the people would be different. The way that they do maintenance would be different. So while the equipment may be the same, your maintenance practices will differ slightly or maybe a lot. So one of the key characteristics for me is relating these changes to what's going on in your system. Is it that every time you do an oil change, you start seeing temperature increases, or you start seeing failures? And just like Andy said, you need to have a record of your failures from before, because if you're noticing a pattern, every 2 years you have to change this bearing. Is that really the life of the bearing? Should it have lasted for about 10 years and it's only lasting for 2 years in your facility? What is wrong? So bringing data into it, and that's why I want to pass it down to Blair. So I'm just going to push it down this way and going to get it there. So
does it look really cool?
Yeah.
You can watch the recording, Blair. You'll
I'm
see.
gonna have to just to see that and then stop there. All right. So I agree with everyone, but I will throw out a challenge there. So when we're looking at lubrication failures, and by no means I'm in the Bob court here on the bottom half of the screen, I think over here. This is the non-lubrication expert zone. And so when I fundamentally look at it, now I don't care if it's a lubrication failure mode or anything I'm trying to detect for the early warning signs. Now, first of all, my suggestion would be, are there parameters or data that you can monitor and learn from that would push you further back on that P to F curve even before the P happens? So the P from Nolan Heaps is an identifiable physical condition, right? So that in a bearing, that bearing has already started to enter its unfortunate slope down. So is there stuff we can start to do? And as Sonya was pointing out, is majority of bearing failures are lubrication related, but we were specifically for those lubrication failure modes, and we want to detect, okay, is it starting to degrade, right? Are we overfilling it and stuff like that? So I think it really comes down to that application. So that P to F curve, and most people unfortunately get it wrong, is it's not a P to F curve for an asset, it's a P to F curve for a specific failure mode, right? And at every lubrication failure mode, I'm sure Sonya could probably tell you, there's probably more than one failure mode of a lubrication, right? So specifically, what failure mode are we trying to detect? Now, when we get to that, now I'll give you an example. So the whole point of what we're trying to do is condition monitoring, is condition-based. I don't like the word maintenance, but condition-based something, right? Condition-based action, right? So what conditions can we measure? And we think about it from a rolling element bearing. Well, the whole point of a rolling element bearing is anti-friction. Can we measure friction, right? As a friction as a first sign. And what we've seen, and you know, Sonya, you pointed out temperature, which I fully agree, but the challenge with that in a real environment is the temperature is also has a high causation as well to environment temperatures and other things. So being able to say that temperature rose because of a bearing issue, or it's just hotter in the room. So it's naturally going to get a few degrees hotter. That's some of the challenges you have with all this data coming in. And that's why you were saying put it to the process data, because if you're mapping what the environmental conditions are and you can get more confidence in that. So I think there are specific conditions per a failure mode, but it really depends on your application. So I'll use, and Andy was talking about ultrasound. Ultrasound essentially is measuring friction in a bearing. Rolling element bearing, that's great, right? You can start to look at slight changes in that friction. But if you go to a sleeve or journal bearing, if you have friction and it's supposed to sit in there in an oil bath, right? I'm doing a bad job explaining this. And if you have friction, it's hitting the walls, like you're too late. You're down that PDF curve. You're banging into things. There's nothing you can do, right? You might have a few minutes of notice or a few hours, but it's not going to be the right measurement. And that's where typically industry would go to a proximity probe to tell the distance from that, right? So it really depends on your application specific. And I think by looking at that and looking at your process conditions, then you can start to map out which conditions would be ideal for that specific failure mode, or take it even deeper, a failure mechanism. But that's a whole different conversation there.
Okay, I'm up. Now everybody's wondering, what's the non-expert going to say? This is not specific to lubrication, but it absolutely, you will, if you do not collect data on the failures that occur on these that lubricants cause, then you can expect to get really good at fixing it more often. So I just want to give everybody a memory jogger that when, from the evidence collection standpoint of doing an investigation, we call it the 5 Ps. There are 5 data categories of data collection. There's parts, there's position, there's people, there's paradigms, and there's paper. Parts are going to be obvious, but if you don't collect the failed parts and be able to read those surfaces, so that people like Shane Turcott and Nev Sachs and all those metallurgists, that they can read the failed surfaces to determine what's happening to it, then you're behind the curve, because it's going to happen again. If you're not collecting samples of the lubricant to find out what's in it, what's happening? Is it breaking down? Is it the wrong lubricant? What any of these things are. Position is what time of day is this happening? Because if you have a trend and you do a scatter diagram and you're finding out this is all happening on the same shift, this is all happening when it's below 32 degrees, right? So we want to look for a trend, and the positions in time and the positions in space. Are we having all these lubrication failures just in one piece of equipment, or is it in like service across the facility? People, who are we going to interview? The maintenance technicians, the people that do the alignments, paper. What type of training do we provide these people, or did somebody retire and you said go ahead and do good things? Or do we have specifications for the lubricants? I think that we all have purchasing. I find this a lot in my line of work. Purchasing is getting bonuses for reducing costs, and maintenance costs are going up because we don't have like for like equipment. We're introducing defects in. So I think that and the paradigm that one of you all said is that I see it in this industry all the time. If a little bit of grease is good, a lot's got to be better. So we also know from technically that's not a very good rule of thumb in the lubrication industry. But it makes logical sense to somebody who doesn't, because then I don't have to come back as often if I put more in. I can miss a PM. And so I just say parts, position, people, paper, and paradigms is true of any failure that occurs. In order for you to be able to solve that failure, that's going to end up being evidence to hypotheses you come up with. To you, Andy.
Funny. I'm excited for all of you to watch the recording and see the way that this is going.
Please, to Heather.
Yeah, to me. I'm on the other side of my screen.
When we look at it, it'll be all wrong and say, what are you pointing at?
Awesome. So super interesting, and I definitely appreciate all of the different kind of backgrounds and perspectives you all bring to that question. Again, I know it was a big one, but thank you so much. Kind of similarly, and I do want to kind of single out Blair with this question in a nice way. I think everyone again will have something to offer, but how does technology come into the fold for solving lubrication issues? How do people use it? What types of technology can people use to predict lubrication failures and get ahead of them before they maybe even happen? Does it automate certain parts of this process, or what does technology look like in conjunction with lubrication failure? And Blair, I think let's start with you, and then we can kind of pass it to anyone else.
So as I said in my opening diatribe, there was technology I think is going to have, or I know it has a big part of it, but you do have to have the foundations, right? If you don't understand the basic principles of lubrication and things like that, no technology is going to replace that. Okay, so there's always going to be that fundamental knowledge and background you need, regardless of how cool the technology is, that's going to be there. So when it comes to the technology that's available or technology you should be looking at, again, link it back to a specific problem that you're trying to solve. So if you know, obviously the whole point is trying to avoid the problem in the first place. So start with things I can do in what's called the proactive domain before the predictive domain. So are there activities and technology that can help me proactively reach that design bearing life, right? Versus there seems to be a race to detect an issue. Hey, I detected this issue earlier than anything else, right? But and that's still great, but you still had an issue. So if we can put a little bit of effort into avoiding that in the first place would be great. Now, when it comes to the fact of using the technology, again, map it back to what problem you're trying to solve, right? Because different technologies can address or help with specific failure modes. And I think what we're seeing in the lubrication space, I'll speak very specific to our product, is it's measuring that friction using ultrasound. Is going to guide you when to lubricate and things like that. And that's hopefully proactive, right? To not have the same fate of those 80% of premature bearing failures is caused by lubrication issues. But that's very specific for rolling ultimate bearings. What if you have an oil system, right? As I said, friction's too late for that. Friction's too late. So we get into oil analysis, right? And what we're seeing is we're trying to, and I think it's great, and there's probably some people on this webinar that are creating sensors where you're trying to get the data that everyone's talking about on online systems, right? So if I, instead of taking a lab sample and sending it to a lab, getting the results, how long does that take? Can I put a sensor in there that's going to give me somewhat similar results? And I do believe they're getting better at that, of using those parameters. But where I think technology is going to come in is, and Sonya, I loved your comments on this, is the space of lubrication is so big, and there's so many things you can measure, from particle counts and little things and water content. And you know, I don't understand them, but I've seen those lab reports that come in, and there's like 10,000 parameters. That's where big data and artificial intelligence is going to come in, because where we're seeing that type of technology starting to get applied is based on my current process, which Sonya was talking about, everything being the same and running, and I have this data, can I start to predict, even if I don't have that online measurement, what those lab results are going to be? And we're seeing that, I'll take a turn, is in pharmaceutical. You make a batch of a vaccine. We're all familiar with vaccines now. Typically when you grow something, you have to take lab results, you send it off. Three days later, you get the results whether this batch was successful or not. They're using AI to start to predict based on all the parameters that went into it, my temperature, my speed, my level. Can I predict what my lab results are going to be with a level of confidence? So I think we're going to start to get to that aspect of technology where we're going to start to predict the oil contamination based on how we've been running it, how we've been treating it, all that kind of stuff, right? So I think technology is going to have a big impact. And I know there's probably people on here that have sensors that can compete with oil analysis that you put into them. But I think, to sum it up, there is a lot of technology. It has to play a big role, because at the end of the day, think about how many things we lubricate in our facility and there's a shortage of people. It's incredible. And they're forecasting a continued shortage in our industry of maintenance, reliability, and oilers and stuff like that. So this technology, I think, has to come in, it has to play a part in order for us to maintain our assets properly.
Okay, let me just pull that up from you there. Thank you.
Jeez.
So I love that you spoke about that and the bringing in of AI, because a lot of people use sensors, and what I find is that they're using one sensor for everything in their facility, and that doesn't work for online condition monitoring. Because if you're doing monitoring for a turbine, it's going to be different from that of what you're going to be doing for a pump. And let's put that in a little more perspective. Your turbine may run 24 hours. It's a critical piece of equipment. You want to have data on that all the time. That's perfect. But if your pump is a secondary pump, you don't necessarily want to have that data clogging up your system, because guess what? If that pump goes down, you can replace it easily as compared to your turbine going down. And then we pull it into the parameters. The parameters that you check for turbine oil, they're going to be different from that you check for a pump or hydraulic oil. So I think right now, yes, we have an influx of sensors and whatnot, but we need to make sure that those sensors make sense. Are they monitoring what they're supposed to be monitoring? Do we have particular alarm limits in place? And then we're going into alarm limits, because with different factories, you have different alarm limits for different things. So even though, let's say Andy is running a power plant and he has some turbines, and I'm running an ammonia plant and I have some turbines, my levels of my alarm limits would be different for both turbines. So we can't have let's just take this out of the box and put this into our equipment. It's going to work because the CEO saw that being done in another company and he thinks it's going to work in this one too. Because I know usually that's how the conversation gets started. But we need to be able to apply the sensors to our equipment, to our environment, our alarm limits. And while sensors are great, they're perfect, they're wonderful, we also have to remember that there is a margin of error involved in any sensor. And certain things, like if you're doing an RPVOT test, you may not have a sensor that can do that, because that's when you take the oil and you're doing the analysis, it has to be run over a particular amount of time. So that's not a sensor that you can have running all the time on your oil. So there are certain things that may not be able to be converted into a sensor format, but we can use other tests to tell us, okay, well, maybe we need to do this test as a higher level test. Use our sensors as baseline information, telling us, okay, this gives us an idea of what's going on. Let's take it a bit further. We should not look to sensors as the saviors of our plants, because sometimes, even though we have enough data, we have the alarm limits, we have things coming on, a lot of times people can't read those. Just like Blair was saying, we get back the reports from the lab, we see so many numbers, and we're like, well, this is great, maybe this should be nice, but we don't know what it means. So I think it's a full cycle in terms of training, getting the sensors sorted out and adjusted to your equipment, setting alarm limits that are in sync with what you are trying to achieve, and then making sure that your people understand it. Because if your people don't understand it, then you're having sensors in there, it's just a nice to have, because nobody's going to work on it. So I'm passing this over to that side of the screen. So Andy or Bob, you can take that from there.
Yeah, I'll go next. Yes, sensors. Well, there's a lot of people in the sensor industry at the moment promising a lot of things. And it's always good to have data, but it's having the right data or finding out the right signature you're looking for in that data. When it comes to lubrication, I'm probably old school. I like to target my assets for volume, fill, and criticality. That's what I'd start with. And then I trust a lab. So if I've got a trusted lab that I can send a jiffy bag off with a sample that I've pulled personally to the standard that I want, the cleanliness standard, I send it to the lab in a jiffy bag, and within 3 days, I can have a result online, and it'll give me a good idea of what's going on with that lubricant. Usually there's 16 fields, so there's not hundreds, there's 16 fields. There's about 4 that I'm interested in. So there's only 4 I'm interested in. That's FE, so ferrous level. I'm interested in if there's any water in it. I'm interested in what they call PQI, so that's particles per million. I want to be able to track that. I also want to take into account that they don't particularly measure particles below 8 micron, because that's the way the lab works. And if there's something specific I know about that oil, I'm also looking for that. So if there's if there's an anti-foaming agent in it with silicon in, I want to keep an eye on the silicon levels. And what I used to do, I used to have a rule of thumb. Anything that had over 25 litres of oil in it, I'm going to send a monthly oil sample, and I'm going to trend that over maybe 6 months a year, and then I'm going to maybe par it back to 2 monthly samples. If there's a particular extruder gearbox or hard work gearbox in say the water industry, I'm probably going to take more of an interest in that than I am in a very low loaded gearbox in an ambient temperature. We go to sensors. So I've worked with companies, I work with software companies that look at the industrialization of these sensors. So the industry of things, shall we call it? And there's lots of challenges. The challenge is when you buy a sensor for, I don't know, $200 or $250, you bought an asset. So now you've got a liability. If you buy 100 of them assets, now you're into thousands or tens of thousands of dollars or pounds, and they become they become something you have to maintain and have their own failure modes. So not all sensors are equal. There has to be, for me, I go from the other end. I go from what does the production actually give us and what are we in business to produce? So if we're in business to produce a ton of Doritos an hour, we want to service that function, and then we work backwards into saying, what ROI can I get out of a predictive technology that will give me a return over time? So oil sampling does, because I used it to run annual planned oil changes, go change it. There were probably about $1,500, $2,000 per pop. We planned those out to kind of 3 or 5 year life cycle, because we did it to the quality of the oil in its environment it was in, rather than just taking an OEM manual and saying go change it every year, and you've only got to decant 100 litres of oil. You've got to put it into a waste stream or recycling stream. There is a safety aspect to decanting and refilling oil, and it probably takes you a few hours as well. And then I've come across people who put the wrong oil in. So I put 100 grade oil in rather than a 320 oil in. So, you know, and that's only been found by oil sampling. And when we went back, obviously, into the CMS system, we found out the oil sample had been done, you know, a couple of weeks previously, and it was done by somebody that had no training. So I think the first thing is, if you can get the training and knowledge right within the workforce that are going to be asked to do these tasks, that's the main thing to do. And then it's the control of your lubrication, the specification, the amount, what environments it's going to be in. All of those things add to your lubricant reliability, shall we say, over time. There's sensors have a role to play, but the sensors I look for is pressure and temperature, and they're pretty basic, they're pretty simple. So as long as my pressure is good, and as long as my temperature is good, and if I don't know it, I use a simple point and shoot on an inlet pipe and on an outlet pipe, and I'll take a delta T of those two and go, am I expecting 5 degrees or 10 degrees temperature change? Just really basic stuff. You don't need to start whacking wired or wireless sensors on everywhere. I've also got a little bit of an issue with the use of the acronym AI. Artificial intelligence does not apply to maintaining or to monitoring assets. Artificial intelligence, unfortunately, was a term. It's a mathematical term. It's nothing to do really with what happens in data fields. It's automated data collection that's been applied, and there are certain machine learning tools, which is a subset of AI, which are being used. That's my spiel on that. So over to Bob, I think.
They could give me that as a nickname, Andy, artificially intelligent.
Yeah. Well, one thing I say about artificial intelligence, when you think about it, artificial means made up or fake, and intelligence. Who can actually measure intelligence? IQ systems are a load of rubbish. So they're both the terms. The term was actually made in 1956 by John McCarthy when he did this summer symposium, at MIT, I think it was, or Dartmouth College, and he wanted to give it a name to the paper that would draw in people into the summer school. So he came up with artificial intelligence, and I think he rued the day he ever did it, because it just didn't work.
Well, I know one thing. I don't want to play Jeopardy against Andy. Heather, can I assume we're not going to get to our case? Can I show the collective thing that me and Sonya were working on?
Yeah, I do want to be respectful of everyone's time. I know we took a little bit longer kind of going through some of those questions than maybe anticipated. So we are just about up at time. Bob, if you do want to show your solutions for solving lubrication problems, please.
Well, it's more what I want to be able to demonstrate here is an aggregation of how do you institutionalize knowledge, and everybody on here are the experts, and I'm just showing that, you know, from my standpoint of what I do as a business is I'm not the expert in the nature of the failure, but we had a case study on deck that we were going to look at where, you know, you ended up with downtime due to a critical pump. Due to a critical bearing failing, due to a lubrication degradation. And the project me and Sonya have been working on is because the questioning becomes, well, how could I have had lubrication degradation resulting in this unexpected shutdown? And when you come over here, and this is what I talked about the physics being determinable, I can have thermal degradation, I can have contamination, electrostatic spark discharge, additive depletion, oxidation, and microdieseling. So all of these are possibilities that exist. They're hypotheses, but then you'd have to come in and say, you know, which of these are true and which of these are not true. So if this is not true, I'm just going to say that it's not true. But I have evidence, and I come over here and say, well, this is true. And I'm going to say, well, how can I have thermal degradation? Well, temperatures in excess of 200 C and or carbon deposits. How can I have carbon deposits? The lubricant breakdown due to excessive temperatures. And how can my temperatures be excessive? I can have overload of related components. So I just wanted to be able to demonstrate cause and effect relationships that are determinable because it's the physics of failure. And if you keep drilling down on any of these, you're going to end up with a human decision to do or not do something, and that's where it gets a little foggier because it's not going to be as definitive as you are in the physics world. So how can I have contamination? Well, I have an ingress of foreign materials. Well, how does that happen? I can get the wrong lubricants, my sealed system is leaking, or I could have defective lubricants from the supplier. So all of this is, I'm not going to get into to go through all of that, but I wanted to be able to show how you can make troubleshooting flow diagrams where people just go in and say, and they're utilizing the expertise of all of these folks up here and saying, you know, here's where you go through and you check, you know, you use those 5 Ps I was talking about, that evidence you're collecting, and what's your true and what's your not true. And you just keep drilling down until you uncover. Inevitably, you're going to find a human, through an error of omission or commission, made a well-intended decision. And that decision, instead of blaming them, that decision is going to be based on something that they believe to be true that was not. And that's usually a procedure that was obsolete, a specification that was never updated, tools you gave them that were crappy, no PM compliance, you know, emergencies took over and we got rid of the PM stuff. So my parting statement with that is that, you know, these are the true subject matter experts in this, and all I do is aggregate logic in logical formats and make sure that we drill it down past the humans, and we find these bad systems that trigger bad decisions, which trigger bad outcomes. And I will hop off my soapbox now. I am in excess, and that probably will be cut off the tape because we went past the hour.
Well, no, we're recording everything. Thank you so much. I really appreciate you jumping in there. I know that there were some questions that we didn't get to, so perhaps we have a part 2 somewhere in our future, but I really appreciate all of you taking the time to share your experiences, your expertise with us on behalf of the audience, the community. Thank you so much for being here. I do want to leave it there. I know we ran 5 minutes over. I'm so sorry about that. But thank you once again for joining, for contributing, and I look forward to talking to you all soon.
Thanks, everybody.
Thank you all. Bye-bye.
Bye-bye.